Assalamu alaikum wa rahmatullahi wa barakatuh. We will start our physics course with the first unit, waves, the second chapter, superposition of waves. At the end of this chapter, you are going to be able to define waves and their characteristics, identify points vibrating in phase and out of phase, state and explain the principle of superposition of waves. Waves are everywhere, whether we recognize it or not. We encounter waves on daily basis. Radios, televisions, guitars, speakers, X-rays, telecommunications, and internet. All the information that comes to us through our eyes or ears propagate in the form of waves. Let's now remember from grade 10. Is the motion of the pendulum a periodic motion? Of course it is. Is it a vibratory motion? Yes, it is a vibratory motion. What about the motion of a tuning fork? Is it a periodic motion? Yes, it is. Is it a vibratory motion? Of course it is. What can you say about the motion of the Earth around the Sun? Is it periodic? Yes, it is periodic motion. But it is a vibratory motion? Of course, no. Consider now the motion of a clock's hand. Is it periodic? Yes, it is. But is it a vibratory motion? No, it is not a vibratory motion. While summing up, we see that both motions of a pendulum and a tuning fork are periodic and vibratory, whereas the motion of the Earth and the clock's hands are only periodic. From this comparison, we conclude that every vibratory motion is periodic, whereas it is not necessary for a periodic motion to be a vibratory one. Now we can define the periodic motion as a motion that repeats itself identically during a constant interval of time called period, and the vibratory motion, a to and fro motion of an object about a fixed point, which is called the equilibrium position. What is a wave? The wave is a periodic motion that transfers energy but not mass or matter. Based on this definition, how can we describe the motion of the duck? If we concentrate on the movement of the duck, we can see the duck is moving up and down. It is vibrating in a vertical motion, and it is not moving in a horizontal direction of propagation of the wave. When a wave disturbs a medium, all of its particles undergo vibration. According to their mode of vibration, waves are classified into two types. The first one is the longitudinal waves, where the direction of vibration of the particles is parallel to the direction of propagation of the wave. As you can see in this document, the particles are vibrating right and left. This direction is parallel to the direction of propagation of the wave. The second type is the transverse wave, where the direction of vibration of particles is perpendicular to the direction of propagation of the wave. Concentrate here on the motion of the red particle. It is moving up and down in a vertical line, whereas the wave is propagating horizontally. The direction of propagation is perpendicular to the direction of vibration. According to their nature, the waves are classified into also two natures. First of all, the mechanical waves, which has three main characteristics. First of all, a mechanical wave needs a medium to propagate in, like sound wave or water wave. Second, they propagate at a speed which is much less than the speed of light, which is equal to 3 times 10 to the power 8, defined by c. The third one is that mechanical waves can be transverse, like sea waves, or longitudinal, like sound waves. The other nature of waves is called electromagnetic waves, which have the following characteristics. First of all, they don't need a material medium to propagate. They can propagate in vacuum. Second, they propagate at a speed which is equal to c, 3 times 10 to the power 8 meter per second in vacuum and in air. While in other transparent mediums, their speed can be calculated by V is equal to C divided by N, where N is the index of this medium. All electromagnetic waves are transverse. These waves are produced by vibrations or oscillations of electric charges. This diagram shows the electromagnetic spectrum, which is the entire range of frequencies of these waves. It is divided in two sections, and the most remarkable section is the visible light, where the frequency ranges between 4 times 10 to the power 14 Hz and 7 times 10 to the power 14 Hz. Let's recall together the characteristics of periodic waves. There are 5 characteristics. First, the amplitude. The amplitude is the maximum displacement or elongation from the equilibrium position. What is the difference between the elongation and the amplitude? The elongation is defined by the position of the particle with respect to the equilibrium position, for example, y1 or y2 or y5 or y8. The elongation may be positive or negative, whereas the amplitude is always positive. For mechanical waves, the amplitude is expressed in meters. Second, the period. The period is the time needed to complete one oscillation. The SI unit of period is the seconds. How to calculate the period? It is equal to the total time taken by all the oscillations divided by the number of these oscillations, which is defined by T divided by N. For example, if 4 cycles are covered in 10 seconds, then the period is equal to 10 divided by 4, which is equal to 2.5 seconds. And if 2 cycles need 10 seconds to be completed, then the period will be equal to 5 seconds. Third, the frequency. The frequency is the number of oscillations per unit of time. It is calculated by the number of oscillations divided by the time taken to complete all these oscillations, defined by N divided by T. The frequency is expressed in Hertz. Notice that the more oscillations covered in the same interval of time means higher frequency. Fourth, the wavelength. It is the distance traveled by the wave during one period or between 2 crests or 2 troughs. The wavelength is expressed in meters. The last characteristic is the speed. Pay attention that the speed of propagation of a wave depends on the type of the wave and on its medium. In the same medium, the speed of propagation remains constant. For example, the speed of typical water waves is equal to 5 meters per second. The speed of sound in air is 343 meters per second. And the speed of light in vacuum is 3 times 10 to the power 8 meters per second. In this animation, we are going to prove that the wave moves a distance of one wavelength during one period. Here, there is a vibrator which vibrates up and down, and as a result, a wave propagates horizontally along this rope. The wavelength of this wave is the distance between the first crest and the second crest, and using the ruler, it is approximately equal to 2.2 centimeters. Now we are going to see what distance will the first crest move when one period is completed. Remember that one period is the time needed to complete one oscillation or one vibration. I am going to move it one oscillation. That means this point is going to move up and then down. Here approximately one complete oscillation is covered, and you can notice that this first crest has moved a distance which is equal to 2.2 centimeters. This distance is equal to the wavelength. We can conclude that during one period, the distance covered by a wave is one wavelength. How can we calculate the speed? We know that the wave moves one wavelength during one period. It covers a distance lambda during time t, which is one period. The general formula of the speed is equal to distance over time, and we know that the wave moves one wavelength or one lambda during one period. Then it is lambda divided by t. It is equal to lambda times f. So the general formula for the speed of the wave is lambda times f. Let us now sum up. First, we know now that the wave is a periodic motion that transfers energy but not mass or matter. Wave according to the type can be longitudinal or transverse. Wave according to the nature can be mechanical or electromagnetic. Wave is characterized by its amplitude, its period defined by T over N, its frequency, which can be calculated using this formula 1 divided by the period, its wavelength, and its speed of propagation, V is equal to lambda times f. Thank you for watching. Please be prepared for video of part 2.